Hello everyone, myself Ved, and today we are going to discuss arrow pushing mechanism. Most of the students have problem with arrow pushing. They don't know what should be the direction of arrow. So let's start here. So first of all, we should know the breaking of bond. Look at here. I'm going to start from very basic. Suppose we have a bond between A and B, and I'm saying electronegativity of A greater than B. So if A is more electronegative, it means it will carry delta negative and this is delta positive. So this bonded pair of electron will move towards A like this. It can be up, it can be down, it doesn't matter. Means we can represent like this as well. Clear? Electron always start from the mid of the bond towards the more electronegative element like this. This arrow is very important. Head will give you negative and tail will give you positive. So as you can see, if you break this bond, B has tail of arrow. Yes, it is mid of the bond, but it is considered as tail over B and head on A. So we can say A is my negative and B is my positive, like this. Suppose I am saying B is more electronegative than A, then we can break like this, and as a result of it, A is positive and B is negative. Makes sense? Plus means both will form A positive and B negative. So this is breaking due to presence of electronegativity. Clear? If you look at this CH3 bromine bond and we have to break this carbon bromine linkage, then we know that bromine is more electronegative than carbon, so it will break towards this. So as a result of it, it will form CH3 plus and Br minus. Clear? So first of all, this is a bond breaking. Clear? Second thing, this arrow indicates the tail of arrow means the electron is away from any atom. Suppose I am any atom and arrow is like away from me. It means I am electron rich. I can donate my electrons. So this is electron rich and this is electron deficient. Clear? In chemistry, we all knew electron rich is also considered as a nucleophile as well as base. So we can say, suppose this is nucleophile and this is, we can say, as electrophile, like this. Clear? Simply, and what kind of electron rich species are? Generally lone pair, negative charge, double bond, triple bond, these are all considered as nucleophile. And electrophiles are generally vacant orbital containing elements, positive charge, Like a general example, suppose you have an alcohol molecule and here you have a H plus, like this. So let me know what kind of arrow direction is correct, this to this or like this. Tell me. Take your time and let me know. So this positive is electron deficient, so how can it donate its electron to the lone pair? Donation is always from rich to deficient, not deficient to rich. So the arrow must be from lone pair of the oxygen towards the H plus, like this. Clear? And this means a flow of electron. Whenever the flow of electron takes place, it means there is a bond formation. So there is a bond formation from oxygen to this hydrogen. So if you want to write down the product of this arrow pushing, we can say like this. It should be like this. R O This one already have a hydrogen H. This oxygen has 2 lone pairs, so 1 lone pair is donated, so still 1 lone pair here. And then you can see flow of electron from oxygen to the H. So there is a bond between oxygen and H. And now look at here the tail of arrow on oxygen, which has a lone pair, and I told you head and tail. Head indicates negative, tail indicates positive. So tail of arrow on oxygen, so here oxygen will be positively charged. And this hydrogen, flow of electron from oxygen to hydrogen, so there is a bond between oxygen and hydrogen, and this hydrogen is neutral here. The reason is that, listen, H plus and here head of arrow. We all knew head means negative. So positive negative on a same atom is going to cancel out. So the net charge on hydrogen is 0, and that's why here no charge on hydrogen. And we all knew this is positive charge. Clear? So positive charge means the electron is towards this bond. Means suppose I am a positively charged. So I will pull the bonded electron. Means arrow should be towards the positive charge. Clear? So now you have two possibilities to break this bond. It can be either this way, means we can break a carbon oxygen bond, or you can break hydrogen oxygen bond. Clear? Only two things is possible. But we cannot break oxygen hydrogen bond. If you're gonna break that bond, it means this reaction is going to reverse in direction. Like you have loss of a proton, so it becomes again alcohol, and every reaction is spontaneous in nature, so it should be break from the R side, not hydrogen. So let's break this one. And we all knew this bonded electron moves towards this oxygen, so there is a loss of water, and this R has a tail of arrow, so R will be positively charged. Makes sense? Charge on R will be positive. Why? Because tail of arrow. Oxygen is here neutral. The reason is that oxygen has head means negative, already positive, so positive negative cancel out. That's why the net charge on oxygen is 0. Makes sense? A very simple one. So suppose I have a PDF of arrow pushing. Let me discuss that first. So here, in this paragraph, the only important line is this one. It is saying the arrow starts at the electron that carbon and bromine share. The reactant and the head of arrow points at the bromine. The reason is that why towards bromine? Because bromine is electronegative in nature. Makes sense? So if any atom is electronegative, it means it will pull the bonded pair of electron, and the arrow will break like this. So as a result of it, we all knew this carbon has a tail, so positive charge, bromine has head, so bromine is negatively charged. Makes sense? Second point, notice that the carbon atom of the cyclohexane ring is positively charged in the product. This is because it has lost the 2 electron. It was sharing with the bromine. The bromine is negatively charged in the end product because it gained the electron that is shared with the carbon and the reactant. The fact that 2 electron move in the example indicated by the 2 barbs of the arrowhead. Notice that the arrow always starts at a bond or at a lone pair. This is very, very important. At a bond or at a lone pair. Clear? At a bond or lone pair means, suppose you have a carbon double bond carbon and you have a H plus. Suppose like this. We all knew double bond is an electron rich, which is considered as a nucleophile, and this H plus is electron deficient. So arrow will start from the double bond towards the H plus. Means it should be, arrow should be like this, the double bond towards the H plus. Now the thing is that if you are going to start from here like this carbon to this H plus, this is wrong. because electron always flow from either lone pair or bond, not the atom. This is carbon atom. So the right way to express this one is like this. Clear? In this way. This is the correct arrow movement. Now the next point, notice that the arrow always start at a bond or at a lone pair. It does not start at a negative charge, and since an arrow starts at a pair of electron, it would never start as at a positive charge. Clear? So we all knew positive is electron deficient. Here Cl is electron rich, so rich donates its electron to positive. That's why arrow is like this, means nucleophile attack over this electrophilic carbon. This arrow indicates there is a transfer of electron, and that's why there is a bond between this CH with this Cl. So here you have Cl and this CH, we have a bond. Clear? Now you can ask like why there is no positive on chlorine, because there is a tail of arrow on the chlorine. The reason is that chlorine already have a negative charge and a positive on a same chlorine. So negative and positive cancel out. That's why the net charge is 0 on chlorine. And same here, this carbon is positive, head is negative, so positive negative again on a same atom. So again it will be 0 on this carbon. Clear? Now this is very important, the bottom one. Look at here. This oxygen is electron rich, this positive charge is electron deficient. So there is a movement of electron from this lone pair to this CH plus, and we know that as a result of it, it will form CH3, CH, CH3. There is no charge on CH, but the reason is that it is already positive, head of arrow negative. So positive negative on a same atom is neutralizes the charge. So this is neutral, and now oxygen donates its electron to this CH plus. So there is a bond, oxygen. It has two lone pair. One lone pair is donated, so only one is left, and tail of arrow on oxygen this time, and no charge on oxygen. Make sense? If this is negatively charged, then plus minus cancel out, but this is neutral and tail indicates positive. So here we have a positive and we have two hydrogens, so one and one like this. Make sense? Like this. Problem 1. Draw the curved arrow to show the movement of the electron in the following reaction. So this is very simple one because product is given here. So we have to only locate the direction of arrow. So as you can see, this carbon is positive, bromine is negative. It means there is a bond breaking between carbon and bromine, and we all knew bromine is electronegative, and you can see here it is negatively charged and it is positive. So the arrow must be like this, because head indicates negative, tail indicates positive. Same here, it will break like this. So carbon positive, Cl negative. Make sense? Okay. Now look at this one, C. In example C, if you look at the product is cyclohexyl ring with a positive and water is a leaving group. So the direction of arrow should be like this. Make sense? This oxygen is positive, head of arrow negative, so positive negative on a same atom, that's why net charge on oxygen is 0. And this carbon has tail of arrow, that's why positive. This is a Grignard one, and you know that Mg is a electropositive and this carbon is electronegative. So the arrow head should be towards this carbon, and you know that this carbon has head, that's why negative. This Mg has a tail, that's why positive. And why the arrow towards carbon? If you look at the difference in the polarity, you know that magnesium is a metal and metal is always electropositive in nature, and carbon is electronegative. Whenever a metal is bonded with any species, metal always carry positive and the atom will be negatively here. This is very simple, electron rich. This is deficient, so it attacks over here, and you know that This is why neutral, because this is negative and tail is positive, so positive negative cancel out. Same here, positive, head is negative, so again cancel out. Next is problem 2. So simple, I think, yeah, it should be like this, and it should be like this, and it should be like this, clear? And it should be like this. The lone pair electrons on Br minus in a part electron have to in E have to be shown in the reactant, because an arrow can start only at a bond or at a lone pair. So start with lone pair or a bond. The lone pair electrons on Br in the product do not have to be shown. It is never wrong to show lone pair, but the only time they have to be shown in the when the arrow is going to start from the lone pair. Again, no need to know these things, we already have done. Bromine is my nucleophile, which is electron rich. Carbon is electron deficient, so arrow should be start from the rich to deficient like this. Simple. And the charge on the bromine is net charge is 0, because this is negative. Same atom have a positive, so positive negative cancel out. This carbon is positive, head is negative, so positive negative cancel out. Now this is something like rearrangement. Here you can see the arrow. When the here you know that positive charge on this atom, and here positive charge on the neighboring atom, this carbon. What happens here? And methyl is shifted to the right side. So simply this is a bond shifting, that is called rearrangement, and this is 1,2 methyl shift. So methyl is shifted to this carbon. Now look at the again the arrow mechanism. Look at here, CH3C, CH3, CH3, positive, CH3. Look at the logics behind it. This is positive. If this bond move to this, what does it mean? Flow of electron from this bond to this. It means there is a bond between this methyl to this carbon, and that's why CH is bonded with methyl. Second thing, the tail of arrow on this carbon, that's why this is positively charged. Makes sense? Simple. And the net charge on CH is 0, because plus and head is minus, so plus minus is net charge 0. Same here, hydrogen is shifted to this. So what does it mean? Now you know that this bond has electron. This bond has electron. So whenever a bond has electron, it means single bond becomes double bond. So you know this CH2 and CH have a bond. Clear? So this is some like rearrangement one, and this is the loss of proton here. This is the loss of proton. You can see here H plus. If you remember the E2 reaction, when the base grabs the beta hydrogen, something like that, it should be like this. Suppose you have a base, any base, suppose NaOH here. So base grabs this hydrogen, this is alpha this is alpha, this is beta, and this bond is donated to this, and there is a double bond like this. Clear? Here we have some example. You know, oxygen is a lone pair. Lone pair is a donor one. So electron always away from the lone pair and negative charge. So it donates electron to this bond, and Cl is a leaving group, so it will leave. Look at the charges after the this activity. So let me explain here. So CH3, C and CH3, these things is not going to change. This oxygen carbon has an electron, so it will become double bond O. Here we have a hydrogen, so hydrogen. And this oxygen has two lone pairs, so only one is left after donation. And you know that tail of arrow on oxygen, so this is positively charged like this. And Cl has head of arrow after breaking, that's why this is negative. Same here, oxygen grabs this proton and it donate the electron to this oxygen. So look at the overall change. Oxygen grab this H, so it becomes H3O plus. Why? Oxygen's tail on this and head over here. So it grabs this proton, so H3O, tail off on oxygen, that's why it is positively charged. And the left part is CH3CH2OH. Why this OH is neutral? The reason is that the head of arrow on oxygen, so plus minus cancel out. Look at this. This is a nucleophile electron rich. That's why away electron is away from this oxygen. Attack on this carbon and this bond is going to break. So look at the changes here. Suppose this is CH2, write down CH2. The neighboring is CH2, CH2. This CH2 is bonded with OH, so OH. And this carbon bromine bond is breaking and this is bonded to this carbon, so here bromine. Makes sense? Simple. Bromine attack over this carbon and this water leaves as a leaving group, so net charge on oxygen water is 0 because plus minus same atom, and this bromine grabs this CH3, so Br CH3. Oxygen again electron rich, so it will grab this proton and then this electron move to this oxygen because it is positively charged, so it will be neutral here. So there is a loss of proton from this OH, so OH is only left and H2O grabs this proton, so become H3O plus. Again simple, OH minus attack over this carbon, Br leaves, so OH bonded to this CH2, so CH3CH2OH, Br have a head, so Br negative. Oxygen attack over this carbon, so look at here. Oxygen attack over this carbon, so it should be like this, CH3C and CH3. So oxygen have a positive, this flow of electron means there is a bond between oxygen to this carbon. So oxygen have a 2 hydrogen and this is positively charged and one is still lone pair. This CO bond is going to break, so it will become single bond and this is OH. You can see. This is simple, this is bond, so electron always from the bond and lone pair, so this is the bond, so its attack over here, Br leaves. So here you have a carb cation and Br minus. Same here, it will grab this proton, it donates its electron to this bond and Br leaves. So look at the result of it. This bond has electrons, so double bond, simple. Br leaves, so Br minus. Minus, and H2O grabs this proton, so becomes H3O plus. Clear? Okay, look at this one. Just look at first the product and reactant, what is happening here. So you can see this is positive charge, so it means arrows towards, look at here the thing, CH3, COH, here O plus HH and here CH3. This is positive charge, so arrow towards the positive charge because positive is deficient, so arrow towards the positive. So now you have two choices, either this or this. If you are going to break like this, it means water is my leaving group, and yes, we have a water as a leaving group. And if you are going to break like this, it means the carbon is still bonded with the OH and only H plus is my leaving, but here no H plus is leaving. So what is happening here? So we can say in this way, this oxygen is a donor, so it donates and water leaves as a leaving group. So as a result of it, this CH3, C, this bond has arrow, so double bond, oxygen have a tail, so positive, one lone pair, H, and this is CH3. So it should donate and it will break. Here you can see electron always starts from the bond or from the lone pair. So it starts from this and attack over this H, Cl leaves, so Cl minus. This CH is my positively charged carbocation and this was CH2. Once it grabs this hydrogen, so it becomes CH3. Ammonia attack over this carbon and Br leaves. You can see Br minus is my leaving group and ammonia donates its electron. That's why amine is positive and bonded to this CH2. This is a shifting of positive in the neighboring position and you can see here H goes here. So positive on this carbon and this CH grabs a hydrogen, so it becomes CH2. This is called 1,2 hydride shift. Again same here, it attacks over here, it breaks like this. So that's why you have a carbocation here and this is water as a leaving group. Same here, nucleophile attack over this carbon, Cl leaves. That's why CH2 bonded with this Cn and Cl leaves. Here you have to only represent the arrow. Product and reactant is given. So you can see methyl alcohol is a leaving. So it donates and it leaves. That's why donate means here positive and positive. Electron towards the bond, that's why double bond. This like this and it attacks over here, it breaks like this. Makes sense? So CH3 attack over this carbon, nucleophile, you can see this double bond break into single, head of arrow over oxygen, so it should be negative. Yes, it is negative. And tail on Mg, that's why Mg is positive. Simple attack over here, it goes here and it breaks like this. O minus attack over here, Br leaves. And this is now the rearrangement again. This time methyl shifted to this carbon like this. Clear? So here you have a methyl and positive charge on this carbon. This is called 1,2 methyl shift. Look at here. What is my leaving group? Br minus is a leaving group. It means it will leave like this. And then H2O is a leaving group. It means this OH grabs this H. And now you know that this bond is shifted to this position. There is a double bond because this bond has a double bond, which means the bonded pair of electron over this bond. This is something like E2 mechanism. And here base will grab this hydrogen. That's why this carbon is, it should be like this. Okay. So carbon has hit, that's why carbon is negative. Ammonia grabs this proton, so it becomes NH3, this NH2 minus. Again a rearrangement, methyl shifted to this position. So carbon is positive, CH has methyl. Same here, oxygen grabs this proton, this bond shifted over here. So here we have a double bond and then H3O plus. Draw curved arrow to show the movement of electron that results in formation of the given product. Again same thing you have product and reactant. So simple thing is that OH grabs this H and it breaks like this. So H2O is my leaving. This oxygen grabs this proton. So tail of arrow on oxygen. So positive OHH plus. Oxygen grab this proton. It breaks like this. So nitrogen is my neutral because plus minus on a same atom. Oxygen grab this proton. So H3O plus. I hope it makes sense. Clear? So this is the first step. This carbon has a tail, so positive. Now Br is a nucleophile attack over this carbon, so there is a bond between them. This carbon chlorine bond is going to break. That's why carbon is positive, chlorine is negative. Amine is a nucleophile. Attack on this electrophilic carbon. So nitrogen positive, carbon, and like this. OH attacks over here, it will break like this. Makes sense? You know that, like this. And now in the next step, there is a bond between C and O. It means there is an electron transfer to this bond, and Cl is my leaving group. So this bond is going to break. Again, take your time and try to understand this. OH attack over this carbon. This bond is O minus. O minus revert the electron. Cl leaves as a leaving group. This is the last page. This is one of the most beautiful arrow pushing. Look at here. This oxygen is here OH. This oxygen is OH and here it is OHH plus. What does it mean? It means protonation. It means lone pair donated its electron to this hydrogen. Makes sense? And that's why you have this H2O only, not H3O plus. So arrow should be like this. So that's why oxygen is positive, one hydrogen like this. Makes sense? Now in the next step, what will happen? Look at here. If you compare these two, the positive charge on this carbon, it means there is a bond breaking of this carbon and OH bond. So it should be like this. So carbon is my positive. Water is leaving here as a leaving group. Clear? Now what is next? Rearrangement. Why rearrangement? Carbon is here positive, but in the next step carbon is here. So it should be like this. Makes sense? So this hydrogen shifted to this carbon. Makes sense? Oh wait, I did something wrong here. It should be like this. Methyl shifting, not hydride. This methyl is shifted to this carbon. So this carbon has a tail. So this is my positive. And one methyl is bonded to this carbon. Now the next step, water is nucleophile, attack over this carbon. And you can see here, no, this is not happening. You can see here, if oxygen attack over this carbon, it means there is a bond between this carbon with H2O, but there is no bond such like that. This is elimination. It means this water grabs this hydrogen. Look at the arrow. This grabs this hydrogen and this bond is going to transfer its electron to this bond. That's why it becomes a double bond. And there is a loss of this proton. Makes sense? So first step is a protonation, then loss of water and generate a carbocation. Then carbocation is going to rearrange in the tertiary position, and then H2O is acting as a base. It grabs the beta hydrogen and generates an alkene, which is overall an elimination reaction. Now move to the B. Alkene grabs this proton, I think. Yes, there is a positive charge and this CH3OH is still left. And now this CH3OH attack as a nucleophile to this carbon. So there is a bond between oxygen and this carbon. You can see OH plus. And in the next step, oxygen grabs this bond and it reverts the electron to this oxygen to neutralize the charge. That's why OCH3 with this. Clear? And CH3OH plus as a leaving group. You can see this thing. This one is this. Simply O minus revert the electron and OCH3 leaves. That's why OCH3 has minus, because head of arrow on oxygen. C double bond O between them, because transfer of electron to this bond. This is already given. Take your time. Simple. Attack over here. It attacks over here and this Br leaves. Water as a nucleophile attack over here. It leaves. It breaks. and then this grabs this hydrogen, it donates its electron to this bond, and then Br leaves. O revert, OH leaves simply. You can do in this way as well. First it grabs like this and then it attacks, and the bond also is right here. Anything is correct, either this way or this way. Means again, suppose this is aldehyde and you have this RMGX, suppose Grignard. So you can attack from this bond or in this way as well. First it grabs this proton, bonded electron, and then it attacks as a nucleophile. So this is also correct, okay, because there is a partial negative on the R, so it attacks as a nucleophile, and this bonded electron rich R, and it attacks as well. So this is all about aeropushing, and I hope it makes sense. So thank you so much for watching this.